My name is Mark Basile. I'm a chemical engineer. I have a Bachelor of Science in Chemical Engineering from Worcester Polytechnic Institute. I've worked for about 25 years in industry, and the majority of what I do is analytical work and figuring out what materials are composed of, why they are what they are, why they do what they do. It's basically a lot of material science is what I do. I started looking into 9/11 from the beginning. I had some serious questions based on some of my readings. An example there would be the R.J. Lee report, and then the FEMA report, Appendix C specifically, that got into some metallurgical analysis of some steel beams that were found from the World Trade Center location, which were actually analyzed by professors at the school that I went to, WPI. When I looked into both the R.J. Lee report and the FEMA report, Appendix C specifically, I just had a lot of questions, so I really started doing a lot more digging into things. And ultimately, in December of 2007, I attended a conference in Boston on 9/11 where Stephen Jones was going to be speaking about his work on the iron-based microspheres. I attended the conference and listened to him talk, where he also, for the first time, discussed his discovery of the red-gray chips that we'll get into a little bit later here. After he spoke, I approached him and I was interested in being put in contact with a source for World Trade Center dust to independently look at the material and either confirm or deconfirm what he had found. About a month later, I received my first sample of World Trade Center dust from Jeanette McKinley, which was one of the individuals that was spoken of in his report on the thermitic materials that he put out in March of 2009, I think it was. So anyway, I received a sample of dust in January of 2008 and basically started working with the material. I found iron-based microspheres in there, just as he had done, and I also found the red-gray chips that he had spoken of. I then began to do some analytical work on them, and I found that their composition was basically exactly what he had described. I was hoping to conduct some experiments with these chips, but I have not been able to get access to a differential scanning calorimeter. So I basically sat and thought for a while about what experiments I could run on these chips to try and, elucidate some of their properties of being thermitic. I created an apparatus where I could basically control energy input to the chips, heating them resistively on a stainless steel heater strip to an ignition temperature, not overheating them, but just bringing them up to the ignition temperature, and then analyzing the resultant products. And what I can confirm also is that these chips, the red layer is thermitic. It does produce molten iron, and I've seen it in a number of chips that Jeanette McKinley supplied to me, and I've also seen it in an independent sample that was also supplied to me from a museum in New York, which is asked to remain anonymous at this point in time. But I've independently seen thermitic activity within two separate independent samples of World Trade Center dust, and I plan to look at more in the next month or so and keep on going. And I guess the other thing that I'd like to say is anybody out there who has these types of capabilities, there's no reason why I should be looking at these things alone. The more people who can confirm, just like I've done, confirming the work of others, the more confidence we all have in the legitimacy of those results. And I'd really like to stress that we need a lot more people involved in this work than just the few of us that are doing it right now that I know of. One of the things I'd like to stress about these chips is that they really shouldn't be there. They're not a natural formed agglomeration of aluminum from the aircraft or materials that were in the building and iron oxide that got knocked off. It isn't just a haphazard bringing together of iron oxide and aluminum, which is the basic components of thermite. This is a material that is made up of nano-sized particles that are all very uniform, very symmetrical. It's in a silica-based matrix that holds the whole thing together, and when they're ignited, these iron droplets that are formed basically eat through the silica matrix and form both droplets, and that actually creates these large relative voids within the residue of the chip that are all coated with iron films inside. If you take these chips and section them and look at them before you ignite them, there are no iron microspheres, there are no iron particles, there are no iron films contained in these chips. It's only after you bring them up to their ignition point point and they go through their thermitic reaction, that liquid iron is produced and the energy is released. These chips are not naturally occurring. They are not going to form because some materials fall down in a building and touch each other and get compressed together. That's just not what this material is. And again, I would say that anybody who thinks that should get some, should look at them, should analyze them, and come to their own conclusions after actually doing some work versus simply just, guessing that something happened. And that's why I did it. I did it because I had questions, and I said the only way I'm ever really going to know is if I get a sample and I do it myself, and that's what I did. And I would confirm that this material is thermitic, and it shouldn't be there. This material is not normal thermite. That's the other thing that really needs to be understood. Anybody could make normal thermite. You can get the ingredients, you can mix them together, you can make them. Any kid could basically do it if they knew the recipe. This material is composed of the real key ingredient that I don't think anybody else could really make in a convenient way is the nano-aluminum. It's a controlled substance. I could go buy it, but the government limits how much I can buy of it. It's very, very difficult to produce in these sizes and to keep from reacting. It's not something that you just get at the local 5 and dime or you're going to make on your own. It's a very, very difficult to make material. And that's the one thing in there that really tells me specifically that this wasn't some guys working in caves in Afghanistan, or it wasn't somebody in their basement doing this. This was, a massive engineering operation that made these materials. Where they came from, I don't know. I can only speculate and guess. But it wasn't something that somebody went off and made on their own. It just wasn't that. I have called for an investigation. I've stood in front of my town at a town meeting and told them about the work that I've done and said that we need a new investigation. To the whole, anybody that was at the town meeting. My work with this has brought me to feel that this material just is too big of an unanswered question, and it really brings us to demand a new investigation, something that's impartial, that's based in science, not avoiding looking at the truth or at anything that, an investigation would bring us to. But this really demands a new investigation. This is hard evidence that can't be refuted by anybody that goes out and gets themselves a sample of dust and looks for this material. It's very, very simple. You just need to follow the cookbook recipe that's been put together by others at this point, and anyone can replicate the work that's been done and confirm that this material is there. There are patents for building demolition with it. Do a Google search on thermite and building demolition. Normal thermite, what everybody thinks of when they talk of thermite, is a mixture of aluminum and iron oxide mixed together in what are called stoichiometric proportions, but that just means there's the right number of atoms to conduct the reaction. And basically what you do is when the aluminum sees the iron oxide and begins to react with it, aluminum is very, very reactive, and it basically steals the oxygen from the iron oxide, and it takes that oxygen and it forms aluminum oxide now, and it liberates the iron from the iron oxide and produces iron. So those are basically the two species that get produced along with a huge amount of heat. So much heat that the iron is in a molten state, which it melts at about 1500 centigrade, and the aluminum oxide is actually molten also, and its melting point is over 2000 degrees centigrade. This produces a huge amount of heat in a very rapid period of time. But basic thermite is just a mixture of aluminum powder generally and iron oxide powder. It can be done with other materials too. The real key is the aluminum along with a metallic oxide, where the aluminum is more reactive than the other metal that's in the oxide form. But that's basic thermite. Practical applications of thermite involve things such as equipment decommissioning in the military. When they have a piece of artillery or a tank or something like that that they don't want to leave behind to the enemy, they throw what are called grenades, thermite grenades, down the barrel, let's say. But thermite does not explode. It simply reacts, produces large amounts of heat and molten materials. And so what it does is it actually will melt a hole through the the steel barrel of the tank or the piece of artillery and render it useless for anybody that would capture that, say in a battle or whatever. So that's one of the typical uses. The other one is the military drops it onto buildings to basically burn them down, or burn through, even it'll burn through reinforced concrete, you know, given enough material and enough time. So the military uses it for a number of different applications. Another one, if you do a search on Google for thermite and building demolition, you can find all sorts of wonderful devices that have been fabricated and invented that use thermite for building demolition. So it's used for a number of different things. The only other real application I can think of is it's actually used for metals preparation. It's a way to produce pure iron or pure copper or various different metals in different thermitic reactions. So it isn't just aluminum and iron oxide. There are other mechanisms, but the one that people generally speak of when they talk about thermite is the mixture of aluminum and iron oxide. An example would be that in 1984 there was a patent issued for thermite cutter charges to be used in building demolitions that could shoot molten iron through the structural steel in milliseconds. The FEMA Appendix C information, which is one of the things that really started me questioning things here. A few of the points that I'd like to talk about there to fill you guys in on as to why I was so interested in this. The FEMA Appendix C that I'm referring to here was basically a metallurgical study. There were 2 or 3, I forget exactly, beams that were found in the debris pile that had they'd been melted. There were sections of them that clearly showed melting. They had sections that were thinned away, and there were actually holes through them, and some of the ends were just melted away or even possibly evaporated away. When I started to look into the report, basically what the metallurgists and scientists at WPI found was that the steel was being attacked intergranularly, preferentially, by a eutectic mixture of iron, iron oxide, and iron sulfide. That's basically what thermite can do. Normal thermite will produce iron, iron oxide in the molten form, but if you add sulfur to it, which is what's called thermate in the trade business, you just add a bit of sulfur, it also produces iron sulfide, and that again lowers the melting point through forming a eutectic, and it just basically makes the steel melt at a lower temperature. So instead of having to bring the steel up to 1500 centigrade, you can slice through it with material that's at 900 or 1000 degrees centigrade. So when I saw that in the FEMA report, you know, that there was actually melted steel, and jet fuel under normal conditions, or really it's just the most aberrant of conditions that can produce those types of temperatures, it's just not what should have happened inside of the World Trade Centers from the fires that I saw, that any steel should have been melted whatsoever. And when I saw those pictures and the work that they did, they talked about it that one of the comments that the professors made was that the melting of the steel could have happened either before the buildings fell or it could have happened after the buildings fell. They weren't really sure, but they left both conjectures open. My contention, based on finding thermite residue in the dust, is that it happened before. It didn't happen after in the fires that ensued in the rubble pile afterwards. It's all the characteristics of the microspheres, along with what I see in the attack of the beams that were actually found, tell me that thermite was involved in melting those steel beams.